Okay, so over here I have a electrolysis setup where there's over for right now this is just plain water, and then I have two carbon electrodes connected to a wire and a battery. So now I'm going to add sodium chloride, which is just table salt, into the solution. I'm gonna add a lot because there's a lot of water. So the reason why I'm adding this table salt is just to ionize the water so that current can flow through the water and the electrolysis can set up. So my electrolyte will be just aqueous sodium chloride. Okay, time to stir. Okay, so now that most of the sodium chloride has dissolved, so now I'll be taking this battery. So for this battery, this side is the negative terminal and this is the positive terminal. So if this is the positive terminal, means that if this is the positive and this negative. So means if I link this wire to this side, which is the positive, so this electrode here will be the anode. And if I take this part, so this is the negative side, so if I link this to here, then this will be the cathode. So okay, so now I'm going to take the battery and I'm going to clamp the wires to both terminals. Okay, so straight away you see effervescence at the cathode over here. So you can see at this side it has very vigorous effervescence, whereas on the left side it is very vigorous, whereas on the right side it's not that much. So okay, so now we will collect the gas by the displacement of water. First I will just fill up my syringe, and then I will put them over here on top. So now we will let the electrolysis run so that we can collect the hydrogen and the oxygen at the two syringes. Okay, so by right, because by the half equations, that the amount of hydrogen formed, so hydrogen is on the left side because the left electrode is the cathode and H plus ions will be preferentially discharged at the cathode. So on the left side, you should collect hydrogen, and on the right side, you should collect oxygen because OH minus ions will be preferentially discharged at the anode. But we know that using the half equations, the ratio of amount of hydrogen collected to oxygen, it should be 1:2. But for some reason, my my setup is not really showing a 1:2. But more importantly, the left syringe, where the hydrogen is formed, there are more hydrogen formed than on the oxygen, which is on the right syringe. So you can see clearly by the height differences, oxygen has only this much, so little amount of oxygen formed. But hydrogen, there's all the way until around 5 cm cube. 5 ml, which is 5 cm cube. But then on oxygen it's like not even 1 cm cube. So it's about like 5:1 ratio. But this is not supposed to be intended. I think that one reason this could happen is because hydrogen is insoluble in water, whereas oxygen is soluble in water. So that could have resulted in a difference in the amount of oxygen collected. So that's why the ratio is not 1:2. But that's for hydrogen. Okay, so we're gonna have a lighted spleen, and it should extinguish with a pop sound. Okay. Whoa! That should be it already.
Damn!
Oh, but then extinguish.
So I guess your spleen is blue. She actually pop eh.
Yeah, extinguish the pop sound. Okay, bye bye.